All right, thanks everybody for joining us this week. The topic this week is automated software image management and how to make your change windows easier. Presenter is Bob Longmore from Worldwide Technology. And with that, I will turn it over to you, Bob.
Thanks, Nick. I should be sharing now. All right, thanks. Yeah, as Nick said, my name is Bob Longmore. I'm a technical solutions architect here at Worldwide Technology. Long history in IT, a lot of different technologies, mostly networking, but the last 3 or 4 years have been focused exclusively on our infrastructure automation practice. And with that, a lot of Ansible, as well as other software, open source, that is sort of around the automation space. And so what I'm going to present today is a version of a talk I did for Red Hat Summit earlier this year. Red Hat Summit and Ansible Fest were combined. And so let's just dive right into this. Software image management, I'll call it SWIM for the rest of this talk. This is a topic that's come up a lot in conversations with our clients and actual engagements that we've done to build the solution. And while all different, depending on the different environments that different organizations are in, there seems to be a common workflow and kind of at a high level kind of things that they want. And the reason why this is important is it allows organizations to keep up with their patching schedules. There are vulnerabilities coming out every day for various systems, and allows us to have a unified framework for and a common workflow for updating these systems. And I think the key to that is a multi-OEM strategy is one, where we can have a similar workflow, whether we're updating Arista switches, Cisco switches, F5, name the technology. And we'll get into sort of the parts of it that I think are important. And so what I proposed is we have this framework that we've deployed using Ansible or other tools. And so with event-driven Ansible, I hypothesized, what if we could use EDA to decouple some of the tasks that are involved in this SWIM process? With some of the key factors being able to reuse different functions of code, different playbooks, different roles, in a different way than we normally would build kind of a workflow within AAP. And ultimately, the goal is to be able to scale this solution so that we can do more in our change windows and maybe even have less change windows. And so let's dive into kind of the way I see SWIM at its most bare bones. We're starting with, I'd like to upgrade a switch. I'm going to upgrade it. Is my upgrade done? Cool, I'm going to go home. In my long tenure as doing these things, both on the customer side and now on the VAR side, there's a lot more to it than that. And I think one of the things that I know I often overlooked is that testing of the state, testing of the device before we did an upgrade in any meaningful way. Making sure that we can upload the code, making sure there's no major errors that pop up. And also on the flip side, after our upgrade is done, being able to test not only is the device up and running, but is the state of the network up and running. In my, again, in my various upgrades that I've done over the years, both as a, working for a company as well as, in a contracting sense as a VAR. Those post-upgrade tests sometimes get missed. It's 3 a.m, you're tired, it's late, you're been staring at a terminal screen for a long time, you just kind of missed something, or you didn't know about this service that was running. And so if we can be able to test that and automate those tests, we can then be assured that we can have safe and speedy deployment of these upgrades. And so if we want to divide these into these three phases, the pre and the upgrade and the post, with the upgrade being really the kind of the easiest part of these three phases. Every system has a prescribed way that you should upgrade it according to that vendor. And with automation, we can usually do that. I said easy earlier. Nothing's ever easy, but it's fairly straightforward to use automation to upgrade a device. I think where the magic comes in, where the benefit comes in, is those pre and post tasks. And so for our pre-upgrade task, making sure that we have all the information about the switch, what code we're going to, making sure our incidents in ServiceNow or wherever are updated. And then that assertion, right? Are my services up and running? Is BGP up and running? Are the services that my network provides transport for up and running? And so we don't get into a loop where we go ahead and do an upgrade and then we figure out this, web service isn't working after the upgrade, only to find out that web service wasn't working before the upgrade, but now it's the network's fault because we did something. And so being able to identify those things that may go into a go, no go decision on an upgrade. And then finally saying, okay, everything is passed. Let's go ahead and do that upgrade. And then similarly, after the upgrade is done, be able to do those same assertions or similar assertions to know that actually this disruption that we caused is fully healed now. And then being able to do things once our upgrade is done, being able to notify people that it's done, update incidents, turn alerting back on, send a message in Slack or whatever it's going to be. Update our sources of truth. But really that assertion is the main focus of what we're going to talk about today. And that's using EDA to kind of chain all of these things together. So let's talk about what that looks like as we talk about automated testing. And the way I view it, testing, simple question, does what I want equal what I have? And so really two ways that I think of it. I think of it like at the device level, the desired configuration. I know I want this interface configured in such a manner. Is it actually configured in that manner? Versus the state or the architecture. I have my network, I have these 50 routers that, have routing tables and adjacencies. Is all of that stuff up and running? Is my BGP the way that it should be? Are my route tables full? Are they populated in the manner in which I expect? And also, are the services that my network provides up and running? Are the web services, FTP, audio services, well, whatever you provide over that network, are those up and running? And so with that, we get into sort of that desired state is really, I think of it as modeling our architecture. And if we can document and model what we want our architecture to look like, that's sort of that infrastructure as code mindset. And so if we can model that configuration, we can also use that for testing because we've modeled that configuration, we've modeled that architecture. We can then take that information about our desired state and compare it to our running state and make sure that they are in alignment. My joke that I've been using for years is that Excel is the world's most popular CMDB, source of truth, IPAM. But as organizations scale and grow, we want to get to something a little more robust than that. And so kind of starting with the YAML and Excel, that's more of like static. We can use those things. ServiceNow is almost ubiquitous in a lot of our customers that we deal with. But what's also ubiquitous is difficulty in maintaining ServiceNow as a meaningful source of your modeled architecture. As a CMD, it's meant for just that, not necessarily for how interfaces are configured, how services are configured. I think in the network world, what we've seen a lot in the last year or two is Netbox and Autobot as that network source of truth. And those are ways that we can model, and they're very network centric, but ways that we can model our architecture. And so here's just an example of using the BGP plugin in Netbox. We can define our BGP information, who our neighbors are supposed to be. And I've kept it fairly bare bones for this demo, but you can, get into prefix lists and communities, and you can get down into the very complex BGP configuration that is sometimes necessary. And so from a programmatic standpoint, kind of bringing this back, what we want, what we desire on the left-hand side. And so we can use Ansible to query Netbox for what we want this device, in this case, BGP configuration, and who we expect our neighbors to be. And then in this demo, we're going to use Arista switches. And so we can use Ansible to go query that Arista switch and figure out the current state of that switch. And so ultimately, we can compare these two. And so we're asking, does what I want match what I have? And so many different ways to test. In this, we're going to stay Ansible native and just use the assert module within Ansible. And we're just going to compare what's in our netbox with what's actually running on the switch. And so we're asking ourselves, is that peer state established with the correct remote device? And are we receiving routes from it? And from that, we can say, if it's successful, we'll do one thing. And if it fails, we'll do another thing. And that's when we're going to tie into EDA here in a bit. If our routing tests pass, we can create an event that EDA is going to look at to go take some action here. So I've talked about EDA a little bit. Let's dive into kind of what that is. And at a very high level, fairly straightforward. Think of it as sort of a companion piece to Ansible. In this case, we'll be using it with Ansible Automation Platform, but essentially does three things. We have our event sources. So where do we want to receive information about, what's happening? In our case today, we're going to use the webhook and the Kafka event source, but there's other event sources that we can make and or use. And Ansible being open source, we can always make our own event sources if that's what our business or our use case requires. EDA, then after it receives those event sources, it looks for conditions. And so we receive this information from our Kafka, and does it match these conditions? And once our conditions are matched, we can then take actions on it. And so there's many actions that we can do within EDA. Probably the most used are running a playbook in Ansible Engine, or running a job template in Ansible Automation Platform. And EDA and Ansible Automation Platform are tied together. They can talk to each other. And in a future, should be coming soon version of Ansible Automation Platform, they'll be integrated in the same UI. And so let's take these three criteria and see what that looks like in an Ansible rulebook. And so traditional Ansible, we have playbooks, and EDA, we have rulebooks. And so we'll define our source. We're looking at a webhook, and we're just listening for events on port 5000. The conditions, we're going to match an event. In this example, we're just looking for a key name, trigger name with the value of webhook. If that condition is met, we'll take some sort of action. In this example, we're just going to print out a message to the screen that says event triggered. So that's a small primer on EDA, and we'll get more into that here as we go through this. And so if we bring it back around to swim and what we're trying to do, we have our source of truth, which is our intended version, our modeled architecture, as it were. And then we have Ansible automation platform that's going to do the upgrading, it's going to do the test, and it's going to make sure that it's going to make a decision if our upgrade was successful or not. And then we're going to, and for these, we're going to use NetBox for that modeled architecture, and Ansible automation platform for the automation. And then we're going to tie in event-driven Ansible and Kafka. And so as we go through this, we are going to do those pre and post tests through Ansible automation platform. And the results of those tests will be put on the Kafka, will be sent to a Kafka broker where EDA is listening, and EDA can take action based on the information that it's received in those tests. And so thinking about decoupling this, I have my rule books and playbooks to do the upgrade kind of in one repo, but then I'm pulling from a different test repo. And so really trying to decouple kind of the tools that we can use from, essentially having those all kind of in one project. The idea being that we can have these tests that can be consumed by many different systems or use cases within Ansible. And so my EDA is set up. I have two sources. I have a webhook source, and this whole thing is going to be initiated from NetBox. And so within NetBox, we're gonna tell NetBox that we want to perform an upgrade on a certain device. EDA is going to listen for that webhook and kick this thing off. And then our Kafka source, it's going to be listening for the test completions, the upgrade completions, and through those Kafka messages, it will chain together that workflow. Using NetBox Docker image, fairly easy way to get started using NetBox. And NetBox has that GraphQL API as well as a REST API, and it also has a inventory plugin, and so we can use NetBox as our inventory for the switches that we have in here. So I'm going to show a very complicated demo workflow, and then complicate it on purpose and show how we can essentially simplify this. And if we just keep in mind that pre-upgrade, the upgrade, and the post-upgrade steps, it's essentially what we're doing here. So when I presented this at Red Hat Summit, I was presenting on the floor of the conference, and I was a little worried about Wi-Fi, but I saw somebody else the day before present live, and so I said, well, I guess I have to present live too. And so here we go, live demo. So here we have our Ansible automation platform, and we have our event-driven Ansible, and we have this Ansible Fest and the NetBox event sources running. And then in our NetBox instance, we have these three devices, and I'll show you our network real quick. I'm just using EvenG to model this here. So we just have three switches connected via BGP, and we have two servers on each end of the network, which we'll talk about how we're using those to test as well. And so let's go ahead and just pick one of these switches. And if we go down here under custom fields, we can see our current software version, and we can also see what software version we've made available to upgrade to. So if we just come and edit this, and we can type in upgrade here, and when I click save, it's going to kick off a webhook. And if we go look at our jobs, we should see that our running quickly, our initiate swim job ran, and now it's running these tests that we have. And so we're running three tests here. our test interfaces is doing that more configuration testing. Is my interface configured the way that I have it prescribed in NetBox? And then the routing, I'm looking to see if we are, if our BGP peering is up, established, and if we're receiving routes from our neighbor. And those HTTP tests in our Eve topology here, we have a web server and we have a user. And so we are, from one side of the network, this user, we are seeing if we can reach that HTTP service that's running on that web server through the network to make sure that service that's running on top of the network is up and running before we introduce any disruption. So we can see these interfaces have, or these tests have all passed, and we're now in this upgrade device playbook. And so what we're doing here is we're going to load that image, and this is like the upgrade portion. And then it'll take a while because it has to reload here. So while it's doing that, let's go look at our event-driven Ansible. And if we look at our NetBox event source, we can see down here that it has received that webhook, and it's matched this, it matched the rule, the condition, and it's now running this job template, Arista initiate swim, and it'll also give us that job result. There's a different way to get that. If we look at our rule audit, we will see these events here and all the information that the event sends into EDA that it can look for, basically traverse that key to look for matching messages and kind of what it's done here. So if we look at our interface tests here, it'll give us a link to the job template in AAP. My DNS is a little screwed up here, so if I click on this, it won't take us there, but it'll essentially show us that job template that was in here. So if we look at our test routing test, we can see that assertion taking place here and the information that it has received. So if we take a look at our, so we are still waiting for this to reload here. So once this reloads, it will kick off another job through our EDA controller. So if we look at our playbooks here, or excuse me, our rule books, here we are listening for that Kafka event source, and we are looking for those conditions of those interface and the HTTP and routing test having passed. And once all those conditions are met, then we'll kick off that upgrade device job. And one thing I didn't show, let's see where this is at. And so we're running this post upgrade. And what I've done in here is I've put in a pause in here just to allow the router to reestablish those BGP peers once it's come back up after the reload. And so we should see this kick off, and it'll kick off another batch of testing here. We look at our tests for our test routing here. We can see what we talked about earlier, where we're gathering information from the router, we're gathering information from NetBox, and then doing assertions on if they, like I said, if they were established and if they're receiving routes from their neighbor. And if that's successful, it's going to use this messages Kafka role to go ahead and put a successful message out on that Kafka bus for EDA to see. And if it matches that the test passed, like we saw earlier, it will kick off that other job. So we can see here that this post upgrade has finished running. And those tests finished running, and we did the service to swim cleanup. And if we go back to our netbox, refresh this screen, we'll see that that current software version has been updated. And if we tried to run this again, one of the conditions in our rule book is that the current software version and the available software version can't be the same. And so it would not meet that condition, and it would not kick off another job here. And so kind of went through all that, and I know I was jumping around a lot. So let's look at sort of what we actually did here. So 2 event sources, we're going to use Netbox to define that architecture and also kick off that job. And so Netbox sends a webhook to EDA to tell it what version of software and what device to upgrade. That is then going to kick off a template that starts testing. And those tests are done through that Kafka bus as well. And so it just puts a message on the bus to say, we want to test HTTP for such and such device. And then those results are returned to Kafka, and EDA is listening for those results, and they passed. One thing I didn't show, and kind of one of the reasons that we could look at to using EDA to kind of do this workflow is those further integrations. So anything that can receive or anything that can consume or produce Kafka messages, we could kind of tie this in, even outside of AAP. And it also allows our tests to be kind of standalone here. And so we could do things like use Slack to kick off a test and get those results back, or tie it into Jira, or essentially anything else that could, speak Kafka and kind of run those tests ad hoc. One thing I didn't show, let me find it here. So if we see here, when that EDA kicked off, I just have a Slack bot that's listening for those Kafka messages. And so we got a message when it kicked off, and we also got a message when the upgrade and all the tests were complete. And so if some of those tests had failed, the upgrade would not complete, and we would also get a message in our Slack telling us what device and what test had failed in there. And this is all just pulling that data off of the Kafka bus. So here's the rulebook. I think I showed that a little earlier, where we have our condition. And so when I type in upgrade, it's going to look for that upgrade. It's going to look for the software versions for the available and the current, and make sure those don't match. And if all of those conditions match, we'll then run that job template in AAP. And the other thing is that we can, from any of these events, we can use event data in our playbooks and pass those in as vars. And so for the name of the device, and that's my DUT variable here, device under test, and the software version, we can send that into as variables into our playbooks. The Kafka messages role, so there wasn't not that I could find anyway, a easy way through Ansible to produce Kafka messages other than kind of using bash, on a command line. So I looked at the event source plugin that Ansible had already published, that Red Hat had already published, and kind of made a collection for a producer using the same Python packages that Red Hat had used. And so I'm just using that role to, at the end of a test or at the end of a step, just to put information on that Kafka bus. And at the time of Red Hat Summit, I didn't have this published, but as of last week or 2 weeks ago, that collection is now published out on Galaxy. So here's what that Kafka message looks like in the upper left here. And we can see that our device name and test name is Arista test interfaces. And so within the body of our payload there, we're looking for test name to equal Arista test interfaces, and it'll kick off that that template that will test the interfaces. And we're passing in that var for what device we want to test. And so with that, based on that device name, it'll pull that information from Netbox, as well as pull that information from that device. And the test results that I was talking about earlier, and I think this is one key feature of EDA is it doesn't have to be just one event. And so here we are collecting information from 4 different events. And if those 4 different events match, using like a Boolean and essentially, if all of these match, and I have a timeout here of 2 minutes, if all of these match within 2 minutes, we will go ahead and run this template to go ahead and upgrade that device. So that's kind of what I had in mind when I built this. And like I said, this swim workflow is something we've done a lot. And even at Ansible Fest or Red Hat Summit, I heard a lot of customers that we don't work with talking about these workflows and just the efficiencies that we could gain. All this information is available. It's in an open repo out on GitHub. So feel free to go check that out. And in that Ansible Fest repo, there's links to the collection on Galaxy, as well as the Arista tests out on GitHub as well. And so with that, we can take any questions. Anybody have any comments?
After you presented this at Red Hat Summit, did you get any people asking you about it for more info, or do you have, because it's pretty complicated. It's a pretty complicated use case that you have here. It's one of the more difficult use cases with BGP peering and so on.
It's a little bit. I did get feedback from, which, I'll brag about here, from a financial customer that said that was the best talk they had seen at Summit that week.
Well, that's good.
But I also had somebody from Red Hat reach out asking, if we could publish that Kafka collection, because they saw value in that as well.
But I think the challenge that you have too is, and I've seen just from past experience doing switch upgrades where you try to automate a switch upgrade in a wiring closet. That's a lot easier to do. In the use case that I observed, they had so many devices on an old switch, they were migrating them to a new switch. The cables are all twisted up and, rat's nest and all that kind of thing. And they wanted to automate it to make sure that all of the devices that were on the old switch got migrated to the new switch. And you do that 100 or 200 times, depending on how many switches you're upgrading and how big the building is and all that kind of stuff. That's relatively easy because, you have a certain model of switch. What you're checking for is MAC addresses. Did they get moved over? Do they show up?
Yeah.
I think it's a lot harder when you have these use cases where you have like a BGP peering routers or edge routers to an internet, because there's so much stuff that runs across those that you don't know about it from a networking standpoint.
Yeah.
Right.
I agree. And, demos always sort of simplify things, but I also think that is kind of the power of automated testing, is that if you, in sort of the old school way, we'd upgrade a router and open up a terminal and, do show IP route and show IP BGP and all that stuff, which, doing that is very error prone, right? And so if we could automate, even a portion of that just to give us better peace of mind, I think it goes a long way.
So one thing, Bob, I hadn't seen this before in your conditional there with the event-driven Ansible. Is that a relative? Maybe it's a new feature, or maybe I've been out of it for a while. But so it's going to see messages within 2 minutes that match all of those criteria. So it's keeping track of the state of as those messages come in.
Yeah.
Until you get to that 2 minutes, and then do a conditional check to make sure they all passed. Is that right?
Well, when it matches that, like when that condition matches, essentially that, like the first time it matches, the timer starts. And so, each Kafka message has a timestamp. And so, if that fourth event happens at 2 minutes and 1 second, then that condition is not going to be met.
But they're all separate. They're separate messages.
They're separate messages.
They're all separate messages. So it's actually collecting a series of messages for that condition within that time period.
That's correct. Yep.
That's pretty powerful there.
All right. For anybody else, any questions, anything that can be answered here? All right. With that, we will let everybody go, get some time back here for the rest of the hour. Thanks, Bob, for presenting. Thanks to everybody for joining, and looking forward to